Hey guys, welcome back for today's Leetcode daily problem. So let's go. So today's problem is number of submatrices that sum to target. Okay, so we are given a matrix and a target. We have to return the total number of non-empty submatrices that sum to target. Yeah. Okay, the problem statement seems simple. So we are given a matrix, a 2D matrix, and we have to find the total number of submatrices in that, like some submatrix like this or some submatrix like that. And if you sum that submatrix, the total sum has to be equal to target. So the total sum has to be equal to target, and even the total sum has to be target. So I have to find the total number of such submatrices, and okay, the problem statement seems similar. So if we let's just go let's try brute force on this. So uh, so to get a submatrix we need 3 unique points. So if we have 3 unique points like this and this and this, if you have these 3 unique points, then we can form a submatrix, because the last point will be this, because the submatrix is a rectangle after all. So so we need 3 points. Okay, so we can choose any 3 points, and then we can find the sum of that submatrix and then check if it is equals to k or not. So that will be like let's say the length is the length is the width is m and the length is n. In that case, the time complexity would be around n into m, and then we also have to find the sum of the submatrix, so which will be again at the worst case it can be like n into m. So it would be n into m, so that would be like 1 2 3 4 1 2 3 4 5, so that would be n power 5 almost. So n power 5, and given n was around 100, so that will be like 10 power 10, which is too slow, so we can't do that. So we can do one thing. We can one other thing is, yesterday we talked about prefix sums, right? So the prefix sums need not be always one directional. Prefix sums can also be two directional. So let me give you an overview of how it would be. So we can choose 3 points like n into m, and then for each submatrix we can find sum using prefix sum and constant time. So n cubed, so that is fine. So 10 power 2 is the size of the array, or is the length of the array. So 10 power 2 power 3 is like 10 power 6, which is fine. We can do that. But to visualize prefix sum in a 2D setting, you have to first understand how they actually work. So we take a 2D we get 2D matrix. Oh, so light the color. I'll use the black ink. Okay, so if you take a 2D matrix, and then what you do is, instead of doing prefix sum in one direction, you also do the prefix sum in the second direction too. So first you do prefix sum like that. So you keep adding. Okay, so the last element of each row would have the sum of the all elements, and like any element in a particular row will have the sum of all the elements from 0 till that row. Fine. So we'll do that, and then next part we'll do this on in the other dimension. So so having that, we'll just do prefix sum like that from top to bottom. So at the end, what we'll get is something like this. So if you take a element like this would have the sum of all the elements behind it and all the elements above it. So yeah, so in a 2D setting, the prefix sum at any each cell would have the value, would have the sum of all the elements of the rectangle that it forms with the origin. Fine. Okay, so so now we know what prefix sum in a 2D setting is, but how do we find length of size sum of a submatrix? So let me show that. It's like similar to prefix sum. It's just like we just have to like bring it up one dimension. So let's say we have this submatrix. We need to find the sum of this submatrix. Okay, so let's say first we take this prefix sum. It would have the elements, it would have the sum of all these elements, like, okay. Here comes the tricky part. So we also subtract this prefix sum value, which would with which we would subtract all these elements, and then we would also subtract this prefix sum value, with which we would subtract all these elements. Okay, we'll remove these elements. So let's start from the first. So we take the sum of the whole cube, the whole square, and then we remove this sum, and then we remove this sum. Then the thing is, we would have removed this twice, so we will add this element, so that we have only removed it once, and at the end we'll have this sum. Okay, fine. Imagine if you had to solve this in 3 dimensions, but I guess once we automate it, we have a generic formula. We can like do it for nth dimension too. Yeah, we can take any 3 points with which we can form a unique submatrix, and then using prefix sum in O of 1 we can find the sum of submatrix. So n cube will be fine, but that's boring, don't you think? It's like, so we have one more interesting approach. Okay, so what we do is, there is one really famous Leetcode problem. Not just Leetcode, it's like a common problem. The name of the problem is, given an array, we have to find the total sub arrays whose sum is equals to a target, a k. Okay, so it's like you have an array. You have to find all the number of sub arrays in this array whose sum is equals to target. So so to do this, we use a really tricky approach. So we know that. So if we take 2 elements, okay, index I and index j, okay, in a prefix sum, okay, so the sum of all these elements is yeah, so the sum of all these elements is prefix of j minus prefix of I, like prefix of I minus prefix of this is like I minus 1, something like that. So is equals to target. Okay, is equal to this sum. So we need to find the total number of subarrays whose target is sum. So if we like, for example, if we are like navigating in this direction, and if we keep storing prefixes in a dictionary, the frequency of prefixes in a dictionary or a hash map or something like that, in that case, so prefix of I minus 1 is equals to, we bring this here and we take that down, this like prefix of j minus k. So we do this. So while traversing, we keep storing the prefixes in a dictionary, like the count of prefixes in a dictionary, like how many times the prefix has been 3 or prefix has been 5. We'll store that in a dictionary, and once we get to j, okay, we'll see how many times we've got prefix of j minus k previously, so that we can like choose those elements and subtract this, so that we'll get target k. So using this, we can find the total number of subarrays whose sum is target. It's a really famous problem. I'll put the link of the problem down in the description. You once go through those problems. So it's just that it's similar to that, but we have to just take it up a notch. We have to take it to the 2nd dimension. So okay, so in this submatrix, okay, we'll find first prefix sum of row wise prefix sum. Okay, we'll find first row wise prefix sum, so that in any particular column, the elements here would have the sum of all these elements from 0. Okay, fine, got it. So now what we'll do is we'll choose any 2 particular columns, so C1 and C2. Okay, we'll do 2 particular columns, C1 and C2. So first in this in this we could have so many submatrices. Okay, so we'll try to find all the number of submatrices whose sum is equals to k. So for that, what we will do is, because first we'll add the submatrix. We'll first what we'll do is we'll keep doing this. Like, imagine this being like this. Okay, then it's just like an array. So the sum of these submatrix, sum of this, okay, this portion in each row is just prefix of c2 minus prefix of c1 minus 1. Okay, so if you do that, then we'll get this row. Okay, so at this, so this will be like the sum of each row in this in between these columns. So in this, okay, in between this, we can like imagine just being this like that, and then we can do the we can imagine this being an array, because this is a 2D array, this is a 1D array, this is a 1D array. So for each row we have this 1D array. So just we'll keep finding the sum like the previous problem, and we can get the sum. We can get all the submatrices here. To understand this, you have to solve the problem that I've stated before. I'll put that in the description. So this is the overall idea of the solution. So let's code it up. The coding, enough talk. So here first let me get the length and width of the matrix. Okay, so once you have the length and the breadth, now we have to find the row wise prefix sum of each row. Okay, so first let me have a prefix matrix which has exactly same length and width as the original matrix. So that would be like, list comprehensions here. So for I in range m, this for I some other thing, for dash what in range, for I in range, this for j in range n. Okay, so we have a prefix matrix, and now we have to find the row wise prefix for each row. Okay, so first I'll initiate the first value with the first matrix value. So that will be for I in range prefix prefix of for each row, yeah, prefix of that row. 0th element has to be matrix of 0 I comma 0. Fine, is that fine? So first element is always the first element. Next, from the second element, we have to add the current matrix value plus the previous prefix sum. For I in range 1 comma n, for I in range n. So for each row, for each column from 1, okay, because we have already filled 0. So prefix of ith of j is equals to prefix of ith of j minus 1, the previous value, plus matrix of I comma j. Yeah. Okay, so now we have the row wise prefix sum for this matrix. Now we have to, like the previous, like the problem we've discussed before, the problem number of submatrices, number of sub arrays in a array whose sum is equals to target. We'll start doing that. Okay, so but we have to do that for each column. So we'll take 2 columns. Okay, for c1 in range m, okay, and for c2 in range, okay, so we need non-empty subarrays. Okay, so the c2s has to start from c1 plus 1. Okay, because we can't like, or we can have the same, okay, we can have a single submatrix with single column. Okay, so we can do that for range okay, so now we have 2 columns, c1 and c2. Now in between we have to do that the subarrays in a array whose sum is target problem. So I'll take a dictionary. I use generally default dicts because it's easier to handle, because when there is no value it gives me 0, and so let me have a prefix, running prefix, okay, from top to bottom, left, okay, prefix is 0 first. But the thing is, in default dict, okay, if there is no other value, like the thing is there is always 0 on the left, okay. So for example, we discussed like prefix of I minus prefix of j is equals to target, but it doesn't always have to be that case. What if the prefix, the prefix of j is itself the sum of the value, that is, we've taken it from 0 till n, so we don't have to minus anything else. So to handle that case, we have to add like prefix of 0 is equals to 1. Hope that makes sense. Hope that makes sense. Does that? See, because prefix of j minus prefix of I is equals to k, right? So uh, what if the prefix itself is value of k? So from 0 till prefix of j is equals to k, then you don't have to minus anything, because so so it's just that, I hope you understand. So we always have an array. We always have a prefix whose value is 0. So I'm just putting 1. Oh, like, so let's get started. So we'll go through each row, okay, for I in range n. So first I have to add the prefix sum, okay, pre plus is equals to. So the value, the 1D array that we found, that we talked about, it is like the prefix of c2, okay, I row, the last for each I, the last column c2 minus prefix of I c1 minus 1. This part we have talked in the video extensively, but this c minus 1, it might be like, if c is 0, then this might go like beyond, outside of the limits, so we have to make a check, okay. If c1 minus 1 is greater than or equals to 0, then only we'll do that. 3 minus is equals to this, okay. So now we've got the prefix sum. Now we have to check if there are any prefixes previously above this in the previous rows, whose if we subtract that from the current prefix, if we get target, okay. So let me have an answers array, okay. So answers variable, so answer would be, if at all, if what was that? So prefix minus, yeah, so if you have to check if this pre minus k is there in the dictionary, like previously we've encountered some prefixes like that, then answer plus is equals to the dictionary of prefix minus k, and then the current prefix also we have to add, so that this prefix can be used in the future. So in answer of prefix plus is equals to 1. So now I think this should work. Let me return the answer. Oh, invalid syntax. For I in range, oh, where is in, huh? Okay, k is not defined, so k is target. Just change it to k. Okay, this seems to work. Let me run this. I hope it just doesn't throw any error or something. Yeah, so that works. But I'm really sick of all these prefix sum problems. I wish some graph or tree problem that will from tomorrow. Yeah, so yeah, that's it, guys. Yeah, so that was it. It's a really good prefix problem question. I don't know why they keep giving us prefix sum problems. First it was DPs, and then now it's prefix sums. I wish next they give us something interesting. So until then, bye. Vaishnav out.